Welcome to Circuit Masterclass, your go-to channel for everything in power systems, transmission, and distribution engineering. Don't forget to check out circuitmasterclass.com for in-depth blogs and bonus content. We have provided the website link below in the description. Let's get started. Here in this video, we shall discuss a detailed theoretical explanation of the shunt trip mechanism of a circuit breaker. Also, we will discuss the series trip mechanism of the circuit breaker. We shall compare these two mechanisms. Also, we shall focus on the advantages of the shunt trip mechanism over the series trip mechanism and vice versa. Then, we shall discuss the disadvantages of both mechanisms. Shunt trip mechanism. In the shunt trip mechanism, the tripping coil of the circuit breaker acts by DC power. There is a separate DC circuit with a battery. This battery supplies power to the trip coil when required to trip the breaker. This is the source side of the power circuit, and this is the load side of the power system. This is the current transformer. This is the coil of a relay. This relay acts due to the signal coming from the current transformer. Now suppose there is a fault in the line. Due to this fault, the fault current will pass through here also, because of which the current transformer senses the fault current. Hence, it reproduces a proportionate secondary current in the secondary circuit. Due to this increased secondary current, this coil produces more magnetizing force, which in turn closes the normally open contact of the DC circuit. As soon as this normally open contact of the DC circuit closes, the DC voltage will appear across the trip coil. Then the trip coil gets energized. As a result, it will trip the circuit breaker by opening these contacts. But here you see, we have drawn a very simple circuit. Here the plunger of the trip coil is directly associated with the moving contact of this circuit breaker. But actually, there is a spring-spring mechanism or hydraulic or pneumatic mechanism in the circuit breaker which stores potential energy. Whenever the trip coil gets energized, it hits a plunger which releases that stored potential energy and thereby very quickly trips or opens the circuit breaker. Here in this work, we have seen that the trip coil does not have any direct connection with the main circuit. Actually, the current transformer is connected in line, in series, and that current transformer actuates a relay, and that relay closes the DC circuit. The DC circuit then supplies power to the tripping coil, and that tripping coil initiates the opening of the circuit breaker. This is the shunt trip mechanism. Now, we come to the series trip mechanism. Here, the trip coil is connected in series with the main circuit. Whenever current flows through the circuit, under normal current conditions, this trip coil produces magnetic force. But that magnetic force is not enough to move the plunger associated with that trip coil. During a fault condition, the current through the circuit will be large enough to create sufficient magnetic force in the trip coil to move the associated plunger. As a result, the plunger moves, and that plunger is mechanically associated with the moving contact of the circuit breaker. The movement of the plunger ultimately causes the movement of the moving contact of the circuit breaker, as it is mechanically associated with the plunger. Hence, it opens the circuit breaker to isolate the faulty zone from the healthy zone. This is the source side of the system, and this is the load side of the system. Here you see the trip coil connected in series with the circuit. Suppose a fault occurs at this part of the power system. Then the fault current will flow through the circuit breaker contacts and also through this coil. As a result, the magnetic force acting on the plunger increases, and that increased magnetic force causes the movement of the plunger, which will strike a spring-loaded lever in the circuit breaker operating mechanism and thereby open the circuit breaker. In this diagram, we have not shown the mechanism. We have drawn it such that the plunger is directly connected to the moving contact of the circuit breaker, but in the actual case, it is not like that. There is a spring mechanism which stores potential energy during the closing operation of the circuit breaker, and that stored potential energy gets released when the plunger hits with sufficient force to unlatch the mechanism. For simplicity, we have not shown all the details here, But for a basic understanding of the series trip mechanism of a circuit breaker, it is enough. Hope you got the idea. Thank you. Both series trip and shunt trip mechanisms have their own advantages and disadvantages. In the series trip mechanism, the trip coil is connected directly in series with the power circuit. It does not need any extra power source, which makes the design simple and compact. That's why it is preferred in low voltage circuit breakers. However, it has limitations. The trip coil must carry the full load current, so the conductor size becomes large. The coil also needs to withstand fault current, which makes it bulky. For high voltage systems, insulation requirements make the design uneconomical. And since it depends on the main circuit power, it will fail to trip during a power outage. On the other hand, the shunt trip mechanism is more reliable for high voltage applications. It uses a separate DC supply from a battery bank, so it can trip the breaker even during a complete blackout. This makes it essential in substations. The drawback is that it requires extra equipment, like a battery charger and DC distribution, which increases cost and maintenance. If the DC system fails, the breaker may not trip. Still, the advantages of shunt trip far outweigh its disadvantages, and that's why it is the most common mechanism in high voltage circuit breakers.
If you found this helpful, don't forget to subscribe, like, and tap the notification bell. Got questions or want us to cover a specific topic? Leave a comment. Thank you.